Hello and welcome back to semester number 2. I'm not even on there. How embarrassing. Off to a bad start. Just kidding. Off to a great start. Okay, this is Unit 4. Lesson 1. Wow. Okay, what's our learning focus? Describe the essential features of a dilation transformation. What? Another transformation? I thought transformations were rotations. You guys just took a test on this. You know about this. Translations, reflections. No one's ever said dilation. What? Yes, it's a new kind of transformation, but it is not rigid. Dilation is not rigid. Meaning that the shape changes its size. It's like squishy. Now the shape does stay exactly the same shape, but it can grow up. So that is dilation. It grows. Let's see. Oh yeah. Some people pronounce this dilation, but it's the same word, dilation, if you've ever heard that, and dilation. It's the same word. It's spelled dilation, or phonetically, so I'm going to try to pronounce dilation. But if I say dilation, I'm still talking about dilations. How do I use dilation to enlarge or shrink a figure? Question mark, question mark. Let's find out. Burnell has a new job at a copy center helping people use the photocopy machines. Burnell thinks he knows everything about making photocopies, and so he didn't complete his assignment to read the training manual. Dun dun dun. Zoom out just a little bit here. That's too much. That's too little. Whatever. Mr. and Mrs. Donahue are making a scrapbook for Mr. Donahue's grandfather's 75th birthday party, and they want to enlarge a sketch of their grandfather which was drawn when he was in World War II. They have purchased some very expensive scrapbook paper, and they would like this image to be centered on the page. Because they are unfamiliar with the process of enlarging an image, they have come to Burnell for help. We would like to make a copy of this image that is twice as big and centered in the middle of this very expensive scrapbook paper, Mrs. Donahue says. Can you help us with that? Certainly, says Burnell. Glad to be of service. Burnell taped the original image in the middle of a white piece of paper and placed it on the glass of the photocopy machine. He inserted the expensive scrapbook paper into the paper tray and set the enlargement feature at 200%. In a moment, this image was produced. Bum, bum, bum. You've ruined our expensive paper, cried Mrs. Donahue. Much of the image is off the paper instead of being centered. And this image is more than twice as big, Mr. Donahue complained. 1/4 of Grandpa's picture is taking up as much space as the original. Is that true? Here they have been reproduced. The original centered and the photocopy. Now these would have been on 2 different pieces of paper, but they're putting them side by side. Notice how they are the same size, but his glasses and mouth is just 1/4 of this. Like his ear's not on it, and his bow tie's not on it. His torso's not on it, so 1/4 of this became this. So Mr. Donahue is trying to argue that it is more than twice as big. And it is more than twice as big by area. It's 4 times bigger by area. However, we will find something out later that's kind of surprising also. In the diagram provided in problem 2, both the original image, which Burnell taped in the middle of the sheet, and the copy of the image have been included in the same figure. I already said that. Explain how the photocopy machine produced this partial copy of the original image. Using a rubber band stretcher, finish the rest of the enlarged sketch. Okay. How was this made? Let me jump few of you in 6th period will have this version. Explain how the photocopy machine produced the partial copy of the original image. Well, it made it 200% bigger. The question is, what's the reference? Like, where, if it's, think of a marshmallow that's expanding. What's it expanding around? The center of the marshmallow? That would be a good, that's what Burnell thought. Burnell thought the picture would expand out of the center of the picture. However, it does not. It expands outward from the corner. So this got, this white margin got expanded out twice as far, and every point on the glasses got pushed twice as far away, which means that when, like, across this glasses, that distance from there to there is doubled down here, and 4 times bigger by area. But if you're talking about just distances, distances are being doubled, and pushed twice as far away from this point. Okay, so if I drew a little balloon, maybe it's a fish, how could I push it out twice as far from there? It would end up, I think, let's see, looking something like this. Twice as far away and twice as big. Everything has been expanded outward. That's how dilation works. Okay, so the answer number 1, explain how the photocopy machine produced the partial copy of the original image. It pushed each point in the pre-image. Ooh, there's our word again. Pre-image. Out twice as far from, oh, if this is the important part, from the upper left corner. Okay, so let's do it. Let's finish it. So the reason why this works is, see if I can get it to work. A rubber band will stretch linearly. It'll scale up linearly. Let's pause here for, you know what, don't pause. Yeah, pause. Okay, I got it. I'm pinning the rubber band up in the corner by my goldfish. I'm holding my tracing pencil at the corner, and look at these marks I put on the rubber band. Now, as I stretch the rubber band, it scales linearly and stretches evenly. So notice how my marks are now at the far corner of the portrait, and my pencil is at the far corner of the new portrait. And now, what I'm looking at is, I'm actually looking at the ink spots on the rubber band, and I am making them follow the edge. And as they follow the edge, my pencil is tracing the portrait. Oop. Now, see, my ink blots are starting to leave, and look at down here, my portrait's line's not straight. Let me try to get back up there. Oh, disaster. Hopefully the way I did it will allow me to just stretch it back out. Okay. Nope. Come on. I don't know if I can rebuild it. We have the technology. Let's try that. Sure. It's a little bit low. All right. So not perfect, but we'll take it. Looks like, oh, my finger was, looks like it's this ink. Oh, this ink dot is the one I'm watching. So now I'm going to jump over to his hair, and if you can see that ink dot back there, what this is demonstrating is I went around his ear there. Ooh, this looks like it's not working. Nope. I'm gonna start over. I messed up my rubber band somehow. Okay, I rebuilt it. So you can kind of see it's the furthest to the left. It's actually on this the bottom rubber band has a little mark. It's a little bit under the mark that is obvious, but that's the one I'm watching and trying to get it to trace along. I'll just go to the back of his nape. Okay. So due to the problem in rubber band technology, this is not working out as good as it should. There's the mark I'm supposed to be following. But if I touch it, I mess with it. Where is it? A key. Alright, where am I going next? Okay, there's that. Let's get his shirt. Can't see behind the rubber band. Okay, I think I'm up to his glasses. Oh, the glass is already there, and look, I'm off. This is what I got so far. Beautiful, huh? Alright, I think this demonstration has run its course. However, let me get, literally, make sure I'm calibrated. I'm going to try to get the rest of his shirt. Oh, and his bow tie. Got to get his bow tie. So the point was one of these points. Man, there's so many. Which one should I pick? I think that one. So, yeah, okay. This way. This is roughly where his bow tie should be. Okay, we'll call it a day there. Beautiful. What I was trying to demonstrate there is that for dilations, there is a straight line that goes from some point that is pushing from. It's called it's called the center of dilation, and the whole transformation of dilation is calibrated from that point, and everything is along a straight line from there. And through that straight line goes the points in the pre-image and the final image. They line up. So like this corner, see this looks, look how the rubber band clips the top corner of the pre-image, and I'm at the top corner of the final image. Here the rubber band goes through the corner of the pre-image, and I'm at the other corner. My point's not calibrated, but it goes along the top of the glasses, and I'm on the glasses. It goes along the bow tie, I'm on the bow tie. So there is a line that goes through each point in the original and each point in the final. And that's how dilations are created with these lines. With these lines that you can trace. They look like this. So it's almost like zooming in. Like, let's go through his ear. And now, because it's set to 200%, equals times 2. This distance, let's call it, let's say it's like 4 inches. Well, then this distance would be 8 inches. Which means you can also figure out this would be 4 inches. But that these numbers only match when it's times 2. If it was times 3, then 4 times 3 is 12, and the second section would be 8. You know, you can but the original from the center of dilation, it's a new center. We haven't had the center before. Center of dilation. It's really good to know the distance from there to a point in the pre-image. From that, you can calculate the distance to the point in the image if you know the scale factor. In this case, this is the scale factor. Where should Bernal have placed the original image if he wanted the final image to be centered on the paper? Well, now you might think at the very corner. That's what I think. But remember, it pushes out from the corner. So if this image was pushed all the way to the corner, it wouldn't push out from the very corner. There would be no border. It wouldn't be centered. It would still be up in the corner, but twice as big. So you do have to have a margin. You have to have a margin that will then blow up to full-size margin. Let's see. If you wanted this to be twice as wide, then that cuts that margin. So a quarter of the margin, I believe. So here's your challenge. Find a formula that takes paper width A, variable A, and pre-image width B to find pre-image horizontal margin that will result in picture being centered. It's some margin. We need a little bit of margin so that when it blows up 200 sides bigger, it's the right size margin to have the picture centered. Because what we want is we want it like this. So I guess it's like here. This is where the original should be. But where exactly is that? You tell me, based on a formula. Mr. Donahue complained that the copy was 4 times bigger than the original. What do you think? Did Bernal double the image or quadruple it? What evidence would you use to support your claim? Both. Distances have been doubled. But since area is distance times distance, side times side, area has been quadrupled. Is that how you spell quadrupled?